Good afternoon, everyone. Thank you for joining us today. My name is Subha Sivanyanam. I lead the Cyber Infrastructure Solutions and Services Group at SDSC and also oversee the TSCC program. Today's training, Dr. Yu Chen will talk about how to get started on TSCC. But before that, I just wanted to provide a brief introduction to the TSCC program. I'll be around after the talk to answer any questions, and also please feel free to type your questions in the chat. I think along with me and you, there's also other STSC staff who work on the TSCC program. Chris Cox, who's our systems lead, and also Ron Hawkins, who's a program manager for TSCC. So the TSCC program started in 2013 and is a medium-scale campus research cluster. The program was originally started to support the research needs of the UC San Diego research community, but now it has grown and we have researchers from other academic institutions and industries participating in this cluster program. The TSCC operates on two different computing models. One is what we call the condo, which is a system purchase model where one buys a node or multiple nodes that becomes part of the TSCC community cluster. The other is the hotel mode, which is a pay-as-you-go model, which is more convenient for researchers who may have a temporary compute or bursty computing needs. So right now we have about 330 nodes, CPUs, and about 50 GPU nodes. And it's a very mixed architecture with different generations of CPUs and GPUs. As being part of the program, researchers also have access to a parallel file system and home file system, which you will cover more in detail. We have around 40 participating labs for the condo program and much more in the hotel pay-as-you-go program. So a little bit more about the condo and the hotel mode of operation in depth. The condo model allows researchers to purchase from a list of CPU and GPU options that we have negotiated with the vendor. For example, for this year, for the CPU options, we're working with Dell, and we have different configurations of Ice Lake-based system that's available for purchase. And once the nodes are purchased, the PIs or the researcher who buys it, the nodes become their property, right? It is the property of that lab or the group, and the TSCC will only manage it as part of this community research cluster. So there is an annual fee and also and one-time infrastructure fee that kind of covers all the common infrastructure like the racks and cables, etc. But the big benefit of buying into the condo program is that you would be able to run on other PIs, the nodes that are purchased by other PIs when it's idle. So sort of, if it gives you that capacity, especially at times when there are some high computing need. In contrast, the hotel users, they purchase time as needed and in increments of 10,000 core hours. The only caveat is that you could only run on the hotel nodes, which are about 35 nodes now. So regardless of whichever mode that person comes in and uses a TSCC, I just want to remind that the entire TSCC cluster is a shared batch system. It's the nodes. It's under the agreement that the nodes that you either purchase and add to the cluster, or the nodes that you're using, are to be shared with other researchers in the same way you are also allowed to use the nodes that are being purchased by other researchers. So one thing is that SDSC has been managing supercomputers for a very long time. So this is one of the big advantage of letting us manage the nodes that has been purchased. We professionally administer them in our data center, which is energy efficient and climate controlled. And being a part of the TSCC community, you have access to a common software stack that has many installed software packages that are commonly used. Or there's always an option that you can also install your own on the file system that we provide. The TSCC also runs a forum which provides you access to other researchers and communities so that you can share tips and information about your own, either about the research or about any of the running on TSCC. So I just want to highlight that TSCC is not just about just the hardware. We also want to say that there are many opportunities for collaboration. The TSCC participation includes basic user support, such as help with logging in, running jobs. But what I want to highlight is that there are possibilities for an advanced user support, which is, you may have a need for performance analysis or a workflow pipeline implementation. I want to build a end-to-end cyber infrastructure development. And that can be done on either a project or a recharge basis. And you may already know this, that SDSC has a long history of writing successful proposals with domain scientists at UC, with UCSD and other institutions. And we want to offer the same for our TSCC community, and we are available to collaborate on proposals. In addition, we also help with your grants in terms of providing letters of support or collaboration based on the funding agency, and also provide any hardware codes that you can include in your grant proposal, and also the SDSC facilities document. See, all the information that I mentioned, including the CPU, GPU options, is available for this year's purchase. Any collaborative, how to engage in any collaboration opportunities, link to the user guide in the training where, including today's training that will be recorded and made available. You can find that all in our new website that you can access at tritoncluster.sdsc.edu. And as always, if you have any questions related to TSCC, just about the program or about usage, feel free to email us at tscc-support@ucsd.edu. So with that, I will end my part of the talk and allow Yuvu to share his slides. And I can take a couple of questions now if there are any.
Okay, so since there's no more questions, so I'm doing my part now. And welcome again, everyone. So I'm very glad to meet you guys here. And next, I'm going to teach the HPC user environment on the TSCC. So here is today's outline. First, we are going to learn and actually see some general cluster architectures. So I will show you some pictures of the supercomputer cluster and how the computer nodes looks like, and we are going to learn some commonly used terms that's used in the HPC, and then we will going to learn some account and allocation basics, and we will learn some policies about how to create and maintain account and what is the allocation on TSCC. And then we are going to learn some software environment on TSCC, including how to access the TSCC cluster, what are the file systems on TSCC, and how to change files, and how to manage your software with the environmental module. In the next part, we are going to learn the job management, which is very important when using any supercomputer clusters, including TSCC. We are going to learn what are the job queues and how to submit interactive or batch jobs. And once your jobs have been submitted and started, how to monitor your job status. At last, if we still have some time, I will introduce some basic job scheduling knowledges. And after that, we will have a Q&A session for you guys to ask any questions you have on the TSCC. And during my presentation, you feel free to type your questions in the chat so my colleagues can see your questions and may answer your questions during my presentation. Okay, so let's go to the first part. So we are going to learn some general cluster architecture. First, let me show those terms in a table. So as a TSCC user or as a supercomputer cluster user, you may have seen those terms a lot, but when you are using using the cluster. So so what is exactly a cluster is a set of connected computer nodes that works together, and each node set to perform the same kind of task. And we also have nodes on a cluster. The node is a single named host machine in the cluster, and inside each node we have cores, or we have CPU. We sometimes mention it as a CPU or processors, and so it's a basic computation unit. Usually on TSCC, a TSCC node has at least 16 cores. Some nodes have 32 or even more nodes cores. And how about the job? So a job on TSCC is a user's request to use a certain amount of resources for a certain amount of time. So if you want to run your program, you will need to start a job. So here's how a TSCC cluster racks look like. So you will see that a TSCC clusters looks like this. There are many racks stored in the data center, and here is a close look inside a rack. So there are several. There are many rectangular units inside a rack that is actually a node. And each node is connected with either InfiniBand or Ethernet, so they can communicate to each other. So how about the a compute node? So a compute node is very similar to your laptop or desktop, but it doesn't have any input and output devices. So it doesn't comes with the monitor, or it doesn't comes with keyboard or mouse, but all other components are very similar to your laptop or desktop. It has a network card, a CPU, memory, storage system, and many of them comes with GPU. Okay, so as you may have known that a cluster has multiple compute nodes, and you are not the only user on the cluster, right? So it's a multi-user environment. So each user may have multiple jobs running simultaneously. Once you log in to the cluster, you will be on some node called the login node. And then you will have access to many compute nodes through a middleware called the workload manager server. So you prepare your job script or you submit your job, and that workload manager server will take your request and then assign your job to one of or many of the compute nodes we have on TSCC. So that's how your job starts there. Okay, so next we are going to have some quick learning about the account and the allocation, because I know many of you already have an account, and so we are going to learn this part very quickly. And how about the account type? So Shuba already mentioned that we have condo program and hotel program on TSCC. So we have accounts created for condo, and we also have account created for hotel. Besides condo and hotel accounts, we also provide trial accounts that has 250 SUs valid for 90 days. And we will learn what is SUs in the when we are learning allocations. But we also, here we are offering trial account. If you don't have a TSCC account, you may consider to have a trial there. And besides the trial accounts, sometimes we also providing training accounts for the technical trainings, workshops, boot camps, or classes started on TSCC, but we don't offer training accounts in this training session. So how can you get a TSCC account? So you can just send an email about your account request to tscc-support@ucsd.edu, including your full name, institutional email address, the group lab name, and if you don't have access to the UCSD AD password, you need to provide us a public key for login. So we will create an account, TSCC account for you. How about the allocation? Because I think the allocation concept is very important in the classical supercomputer cluster environment. On TSCC, by default, you don't maybe when you submit your job, you don't need to specify which allocation you need to use. So that as a result, I found many of our TSCC users actually don't know what is a allocation, and they don't know that there is an allocation on the TSCC. But here, so let me talk about what is a allocation then. So allocation is a block of service unit. It's called SUs that allows a user to run jobs on our supercomputer clusters. So one SU is 1 phone hours. You will, for example, so in this example, so you will be charged 40 SUs for a job that runs 10 hours on 4 CPU cores. So you can do the math by yourself when you run your job. And TSCC, almost all TSCC jobs need to be charged to a valid allocation, except for the jobs running in the green queue. So we will introduce those queues later, but just keep in mind that you do need to you do need a valid allocation to run jobs on TSCC. And remember this picture Shubha showed us earlier. So we have a condo users and we also have a hotel users. There are 2 different programs. They all need allocations to run jobs on TSCC, but there are 2 different types of allocation that they can have. A condo allocation can be is created annually, and at the beginning of the month, that nodes were added to TSCC, and we have equation to calculate how many SUs can be created each year, and those SUs will expire 1 year after. So there's no rollover of leftover SUs. On the other hand, as the hotel program is a pay-as-you-go model, so allocation can be created at any time of the year, and you just pay a premium to purchase some SUs, and there's no expiration date for the SUs in the hotel allocation. Okay, so to request or join allocation, you can send your allocation request to us, and we will handle it. We will handle it and add the SUs to your allocation once we finish any necessary steps or procedures. So next, we are going to talk about the software environment on TSCC. So I think that's very important for you to learn. So first, we are going to learn how to log in to our TSCC clusters, right? So we need some method to be on the cluster, and then you can do your job and do your work there. If you are Linux or Mac OS user, the easiest way for you is to use the SSH command on a terminal to connect to our TSCC clusters. If your local machine is running Windows, say Windows 10, maybe you need to download a SSH client in order to connect to our clusters. Here, I would recommend the Mobile Extern, which is easy to install and use, and has many powerful functions integrated inside it. Also, you can choose Party, which is a very classic SSH client for Windows users. So in order to log in, you need to provide your account or username, which is assigned by us. And if you are UCSD user, you need to enter your UCSD AD password. For non-UCSD users, you will need to create a SSH keys for the login. And if that's your first time to log in, you need to send your public key to us first in order to log in. And the host name of the TSCC is, as I highlighted here, tscc-login.sdsc.edu. So every time you log in, you either need to type this host name, or you need to save this host name to somewhere, to some sessions, so you can log in to the TSCC by this user host name. So here's the exact Linux or Mac OS command you need to type when you are logging. So the command is SSH, and you can enter your username and add the host name. And please note, the host name will bring you to different login nodes. We have multiple login nodes. Right now, the login 1, login 2, and login 11 or login 12 are open to almost every TSCC users. You don't need to specify which login node you need to go, because the tscc-login.sdsc.edu it's a round robin, and it can take you to one of the login nodes. So that host name is enough for you to log in. Once you enter this command, SSH command, you hit enter on your keyboard, and then you can enter your UCSD password, or if you don't have a UCSD AD password, you will need to use SSH keys for logins. Okay, this will be some instruction about how to create a SSH key pair on a Linux local machine. So I won't mention talk about this in detail. just want to mention several things. First, make sure you have a password on the private key on your local machine. So that's very important for the security purpose. And please keep your private. Once a SSH key pair is generated, you will get two keys: the public key and the private key. So you need to keep your private key in somewhere. So you don't share your private key to anyone else. So because it's called private key for a reason, right? So since it's private, you don't want to share it to anyone, including us. You don't want to share your private key to the TSCC. But on the other hand, the public key you need to properly install on the TSCC. So we TSCC can help you install your public key for that. And then since you create a password on the private key, you can consider to use a SSH agent or keychain to save that password. So you don't need to type the private key password every time you log in. So it can save you some time to type your private key password. So I also have an instruction link here. So that website gives very detailed instruction how to create and maintain SSH keys. Okay, how about the Windows user? So Windows user, you have a choice to use various SSH client. So the one I'm showing here is the mobile term. So once you install the mobile term and open its graphic user interface, you can either start a local terminal, as I highlighted here, and then you can type the SSH command on that terminal, just like we were saying in the previous slides. So it's just the same as the same Linux SSH command. Or you can start a new remote session, as I highlighted here, and you can then enter the host name, which is tscc-login.sdsc.edu, and your username, and then that session can make your login to TSCC, and you can save that session later. So in your later logins, you will find it under the saved session and on the left panel. So the next time you just double click that saved session and log in there. As a party user, so it's almost the same. You just need to end the host name there, and then you choose the connection type as SSH, and then you maybe need to enter your username as well, and then you enter your password. So it will take you to the TSCC login cluster. Okay, here's the details about how to create a SSH key pair with mobile term. And again, I won't mention this in detail, but you're welcome to let us know if you have any troubles or problems when creating or using the SSH keys. So next, I know some of you folks want to use the graphic user interface on the cluster or on the TSCC. We call that graphic user interface as a GUI. So if you wish to use GUI, you need to enable the X11 forwarding. So how to enable that forwarding? You can add -X or -Y options in your SSH command line, and then and then after your login, you should be able to have the H11 forwarding enabled. And if you are using Windows, first you need to make sure that you have installed the Edge server. So Edge server is a tool that help you to set up your H11 forwarding on your local machine. But if you are using mobile term, that Edge server will be set up automatically, so you don't have to set up the Edge server. So you just check the H11 forwarding in the mobile term, and once you log in, the H11 forwarding will be available to you to use GUI. Okay, so let's see the, okay, Shu already answered the questions. Thank you. And now let's have some quiz or test. You have feel free to answer answer it in the chat. So let's see if you if you got my idea or not. So here is my question: how do I connect to the TACC? So we have three options. First is open a web browser, enter the TACC website address in order to connect to TACC. The second option is use SSH command or SSH client, such as a mobile term or party. The third option is go to the machine room in the SDSC data center and connect your laptop to the nodes using a cable. So what do you guys think? Which one is the right answer? Okay, let's see the answers. Yeah, I think that's easy and straightforward, right? So the B is the correct answer. You will need to use either the SSH command or SSH client to log into TACC. So our website is providing some very helpful information, but we don't use it for the login purpose. And the same, the last option, go to our data center, the machine room in our data center. No, of course no. So you are not invited to do that. So since we have a very convenient SSH tools for the login purpose. And thank you guys for providing your answer. And that's just want to make sure that we are on the same page. And okay, so I will talk about this question: how to launch the Jupyter Notebook from TACC server, or my colleagues will help you with this. Okay, so once we log in, we have some commands available for you to monitor your accounts and allocation usage. And the next, I'm going to talk about those commands. So the first command is called ID. Yeah, it's just ID. That's it. So once you type ID on our in the terminal after you log in, you will you will get the output from from that ID command to know which Linux groups of the account of your account is belonged to. So in this example, you see, I type the ID and I found that I'm in different, I'm in many different Linux groups. Why it's important? Because the Linux group is will be used to determine which compute nodes your job can be submitted to. So we will talk about the job queues and job submissions later. So here we just focus on what can we do get from the IDE command, and sometimes you need to be added to a certain Linux group in order to use some software. For example, here I have been added to the Gaussian group. So if I don't I'm not my account is not added to the Gaussian, I don't have access to the Gaussian software. Okay, besides the next command I'm going to introduce is called a gbalance. You see that I even increase the font size of this command. That means this command is very important for you to monitor your allocation usage. And so how to use it? You can just type gbalance and then -u and then your allocation, your username. So this example is for checking my allocation on TSCC. So I use my username YCHEN64. So what I can get from the output, the first is I see the name of my allocation, which is called builder-group, and how much SUs, how many SUs are there in my allocation? It's like 78,000 SUs currently available in my allocations. So if I'm running some jobs, I might see some numbers change under the reserved column or something, some numbers there. But in general, that's you can get to know your allocation name as well as your SU balance in your allocation. Okay, there are two other commands you may need to use in order to monitor the allocation usage. The first is called GLS projects, and you can use this command to check who is in a certain allocations. So, for example, if you are PI or if you are managing your allocations, you use this allocation to check who are all of the users in these allocations. And if you don't want some of them to use your allocation, you can then let us know. And the G statement is an allocation, is a command that generates a summary of all activities on the account. So you type, you gave some options to this command. You either use a -u option or -d options, and then times a start and end time, and then it will print out a summary of all activities on that allocation. Okay, so after we learn some commands, next I'm going to introduce the TSCC file systems. So the TSCC file systems in general are accessible from all nodes, including the logging nodes, compute nodes, GPU nodes, and data movement nodes. Every TSCC user will have a home directory, which is your /home and /your username, and it has a 100 GB space limit, and It's used for saving your source files and small input files. Sometimes you can put some software there, but that's not for heavy IOs or not for running jobs. So please try not running any jobs and write anything to your home directly, because we have a lecture. We have our next lecture 5 systems for you to run jobs. So the lecture 5 system on TACC is /OSIS/TACC/Scratch, and that's good for storing large-scale Scratch data. That's a shared parallel file system designed for running jobs, and it will give very good performance if your jobs are running in parallel. But just keep in mind, there's a purge policy on the lecture file systems. So if your data or your files are not used, are not accessed after 3 months, they will be subject to be purged. Also, besides the home and the lecture, we also have projects file systems, but that's not managed by the TACC. And we are offering these file systems for some groups that have extra or external or extra storage needs, and then we will refer those research groups to use projects storage, which can be purchased and managed by the SCRDS group. So on each compute node, there is a local Scratch, and the environment variable to access that local Scratch is $TMPDIR. So that's a local Scratch for the compute node, and is good for the writing small files. That Scratch has around 220 or 270 gigabytes. But please note that's a temporary Scratch, and the data saved there will be purged at the end of running jobs. Okay, so we have some storage on the TACC. You might want to know how to transfer your files or your data to the TACC in order to run your program. So if you are Linux or Mac user, you can simply use the SCP or rsync command to copy your files to the TACC. But please note that if you have hundreds of or thousands of files to transfer, please try not to transfer them one by one. Instead, please zip them into a large single file. Like you can use a zip command or tar command to zip them into a large single file, and then SCP, or you use SCP command to transfer that large single file to the TACC. So that would be better for both of us. I mean, it might, you might see your transfer speed, will be better when transfer a large single file, and also on the class side, our cluster will be less impacted by your file transfer. Okay, so how about you want to download something on our website? So usually you see some download link on when you're opening some website in the web browser. What you can do is you right click on the link and then copy the link location. and then you went back to the cluster, TSCC cluster, and you use the wget command. Wget command is wget, and then you copy and paste your link after the wget command, and you hit then that contains in that download link can be downloaded to the TSCC directory. So that's the way you don't have to download it to your local machine first and then upload to the TSCC. So how about other tools and techniques? We have a Globus available on, for the file transfers on TSCC. So I listed how if you want to use Globus, how to set up your Xseed account and how to transfer the files. If the other end of your if you have access to the Xseed account, or you have access to the Globus. And what if you want to move to transfer large files? So we have a data mover node that is designed for such file transfer. So if you want to use the data mover node, once logged in, you type that command SSH TSCC-DM1, then you are going to the data mover node, and then you can download the files there. Okay, so one more tip for the Windows users. So as a Windows user, your SSH client may comes with a GUI, right? So you will see some Windows in your SSH client. So here is an example of the mobile term. So once I log in, on the left side of the software panel, I can see my directory of the folders on the TSCC clusters. Then I can choose the upload or download icon, and then I can just choose which files I wish to transfer. But again, please pay attention that if you have hundreds or thousands of files to transfer, you'd better zip them all into a large single file before you before the file transfer. Okay, so what is what software is available on TSCC then? And here I make a brief list about the installed software on TSCC. We have mathematical and utility libraries. We have many applications for simulations, and we have visualization tools, programming tools, some other software. And here is a list of the software on our website. But generally speaking, you don't have to go to our website to check the software list. I will show you how to check the software available system widely on TSCC. So all system widely installed software is under the /OPE or /projects builder group and JPG, and we installed our software there. If you want to install your own software, generally speaking, you're encouraged to install them in your own space, like in your home directory. Or if you want to share those your software with others, or if your group wants to install some softwares, we may install it under the projects directory, or there are several research groups want to use some softwares. We might we may consider to install the software system-wide. And if you are a Linux user for a while, so you may know that we access those installed software in Linux through the environment variables. So we need to set up several environment variables in order to access those softwares, especially if those software is not installed in the default locations, which is the case in on our cluster. Because our cluster, you see, the software is installed under the /opt or /project builder group. Those are not default locations. So there will be some environment variables needed in order to access those software. However, you don't have to set up them in general because we already provide a very useful environment tool called the environment modules that can help you to set up your environment variables. And that environment modules are widely used on most of the supercomputer clusters. So next, I'm going to introduce how to use environment module on the TACC. So environment modules is a framework to manage what software can be loaded into your user environment. So there are many functions. I listed them here. So let's look at them one by one. How about we want to know what kind of what software is available on TACC? So if you want to know that, the first command you need to run is called module available. It's called you can just type module AV and then hit enter on the TACC, and then you see that all software installed system-wide and available to you will be printed out. And you can see that the results, including the software's name, for example, the MATLAB, and then a slash, and then the MATLAB's version. So all softwares in the module output looks like this. And if you want to access more modules on TACC, we have put some software applications at the projects builder group, that's JPG, but that those modules are not visible or not accessible by default. So if you want to access those modules, you need to add the module location to an environment variable called a module path, as I listed in the last line here. So I can export module path equals to that location, and then including the original locations of the saved in the module path. So after type that command and hit enter, and then if I type if I run module available again, I will see some software applications modules installed at projects builder group JPG. Okay, so we know how to get all of the seasonal widely available softwares, but how do we know that which modules are currently loaded to our user environment? So that's the module list command do. So you can just type module list and then hit enter. As shown here is it's very easy to understand, right? So currently I'm loading two modules. The one is called Intel 2018, and another is called OpenMPI. So if you want to load or unload a package, so you can use the module load command or the module unload command. So which is, and then comes with the package name. For example, module load the MATLAB module load MATLAB. So if we wish to, or shown in the example here, so module load CUDA. But if you want to load a specific version of that software, you can add the slash and the software version in the module key you want to load. So here is the example of the module load CUDA 11.2. So if by default the CUDA 10.1 will be loaded if I just type module load CUDA. So how about what if I want to load module module of CUDA 11.2? I use the command called module load CUDA /11.2.0, and that I can verify the CUDA version I have loaded. So that's how to load a specific version of a software. And what if I want to unload all of the loaded module files? I can just use the module purge command. The example here showing that I have 3 modules loaded: Intel, OpenMPI, and CUDA. After I type module purge and then double check with the module list, I see the result is no module files currently loaded. And please note that modules will load any dependencies for a package when that package is loaded. So the module list, we don't have any module loaded in this example. Then I typed module load GROWMACS 2021.1, and then I type module list. I will find that not only the GROWMACS module is loaded, but also 3 dependencies of GROWMACS are also loaded to my user environment as well. You see that the MKL, Glue, and the Intel MPI. So that's how the module load works when loading some software with dependencies. And if you need to know what exactly a module load command can change the environment variables, you can use the module display commands, and you will get how the environment variable changed from the output. For example, here this result shows how the Python, when the Python module is loaded or unloaded, how those environment variables will be changed. And if you want to load some modules automatically at login time, you can save that module load command into your .bashrc files in your home directory. So that's the example I'm showing here. It's .bashrc, and I saved this two module load lines into my .bashrc. So every time I log into the cluster or my job starts, those 2 modules will be loaded. So I have access to those software. Of course, if you want to create your own module files, you can do that. And I won't introduce this in detail, but I included I gave an example of a simple module file here, and it's also available on the TACC in my home directory. So you can go there and take a look at how that module file looks like. So once you created your module file and save it to somewhere in your home directory, you can then add the path to the key to that module path environment variable. Remember that environment variable controls the path of the module you can see in you can access to. Okay, so I have done my introduction about how to use the environment modules. But here's the homework for you. So I don't think we have enough time to practice this in today's training, but I encourage you that try this this homework, and there are some other homeworks for you, and I hope you can have an idea about how to use modules through your practice. Before jump to the next job management, let's see the chat, and see Shuba and Marky are helping answer those questions. Thank you so much. And so I don't have to answer them. Thank you. So the next part will also be very important, because that's about the job management. So in this part, we are going to learn how to what is a job queue, and how to prepare and submit a job, and how to monitor a job at your job's runtime. So basically that's the daily work you need to do if you are using TACC. Okay, before we jump into the job submissions, please pay attention that do not run your computational programs or applications or codes on the login nodes. Even for some simple tests, as you consider. So you may think your code is short, or you may won't take too long, but that will impact other users on the login nodes. So please don't try not to run your programs or applications or codes on the login nodes. And those login nodes are meant for the login. So please see the pictures or diagrams. I show this again. So every user, when every user is logging through the login node, and then on the login node, they are preparing their job scripts, or they prepare or some tests, or they're editing their codes, or some simple tasks like that. That's good. That's okay. Because they don't use too much computational resources. And then remember, there's a job scheduler system that will take your job and run your programs on the compute nodes through the job. So that's what your programs or applications or code should be run on. So in order to run the job, in order to run any jobs, you might need to find the right queue for running your jobs. So you need to understand the queuing systems, and what your requirements and how the jobs queued in the queue. And we then you prepare your jobs and submit your jobs, and at this time on TACC, the job script is in the PBS format. That means that's because the PBS we use PBS job schedulers to schedule your jobs. And when your job is running, again, please monitor your job. And I will I will introduce some very useful commands for the job monitoring later. So so how about we learn some job queues knowledge first? So various queues are available to access to the computer nodes. So the queue access is through the access control list. So it's remember I mentioned earlier, your Linux group determines which queues you can submit your job to. So in each queue, there might be different there might be different in the number of the available nodes, or the maximum runtime you can have, or the max running jobs you can submit it to. And each nodes may also may have special configurations, or for example, some of them have GPUs, or some of them have less CPU nodes, or some of them may have InfiniBands for the inter-node communication. It's recommended to specify the resource requirement, and I will introduce this later in detail when you in the session when we are when we're talking about how to submit the job. But please note, I highlighted in the last part of the slides, right? So it's called a queue for a reason. But jobs don't run on a first come, first served policy. That means if you submit a job first, maybe or maybe not, your job won't start the first. And let me ask your guys a question. Why is not a first come, first served policy? So think about it. So it's we are employed in a queue, right? A job queue. So
does it have to do with the wall time?
A part of, yeah, a sort of, yeah, a sort of it has to do with the work time. And also we have the job scheduler has some algorithms to control which job can start after start first, because they want the job scheduler want to make use of every computational resources available. Imagine that if it's a first come first served policy, if there's a first come first served policy for the job running, a user submitted 1,000 jobs. Each job lasts for 3 days with the TACC. So, or if that's first come first served, so all other users have to wait for his 1,000 jobs finished after 3 days, right? So nobody will be happy with that. Okay, so which tools are available on TACC then? So still we divided into the condo program, condo queues, or condo programs, or hotel programs, and I listed which tools are available on TACC, available to the condo users or hotel users. And in general, all users have access to the hotel queue, the GPU hotel queue, and the big memory queue we call PDFN. And I listed some numbers that related to the queue. And also, if you are condo users, you have more queues that you have access to, especially for your home queue. You may find that the limits on your home queue is much less than using other queues. So how to get those numbers I listed here? You don't have to went back to our training slides later, but you can use some commands to find out more about the queues. So the first command you can use is called queue-stat-q. That command will give you more information on the queues as I listed here. And you can also use the show queue command. That command will print out all active eligible jobs and blocked jobs currently on the TACC at the time of you run that show queue command. And also, if you want to know the nodes availabilities, there's a very useful command called ls jobs on TACC. And I list the example here is if I want to know the availabilities of the nodes in the GPU hotel queue, what I'm typing is ls jobs -- property, and then equals to GPU -hotel. I then add -node. That's the name I need to include in the ls jobs command. And you can see that the output is showing that there are five GPU hotel nodes, and one of them is running jobs, and some are not online, and you can get similar results in your ls jobs command. So how about we move to the job types? So we have two types of jobs in TACC, and they are all submitted by the PBS job scheduler. And the first type is called interactive job. So you set up an interactive environment on the compute nodes. The advantage is you can run your programs or you run your commands interactively. So you can see and you type your commands in the terminal as usual. Once the job starts, and you can see the output on your screen directly. So if there's something goes wrong, you can catch it. But you don't have to kill the job. But the best thing is you have to wait the job starts, and you need to interact with your script or with your programs running some when the job is running. The second type of the job is called the batch job. So we're preparing a job script and submit a batch job. So once the job is submitted and started, the system takes care of everything. So that means once it's running, you don't have to sit in front of your laptop, or you don't have to stay overnight in front of your laptop and worries about the runnings, unless your job is crashed or terminated earlier. So, but the downside is once it has started, it's very hard for you to change the commands included in your job script. So you you will find that you will end up with delete your job first, and then you modify your job script and change your commands, and then you need to resubmit your job. And usually we use the back job for the production run. So you say you are ready for run your program for a long time and get some very useful results for your research. So how to submit interactive jobs? You can submit it by this qsub command. The necessary option you need to include is called -I. That's a capital letter I, and then you give some you specify the resources you need and which queue you want, and the real commands. Example here. So here is my qsub command to submit a interactive job. So you remember the first, you need to give the qsub command -I. That tells the job scheduler you want an interactive job. Then you can add a -X if you want to enable X11 forwarding to use GUI, and then a -L. And the -L accepts the length of the job time you want to use. Here is 30 minutes. And also the -L is used for specifying how many compute nodes and the cores per nodes you want to use. Here I am using 1 compute node and 16 cores per node. And then -Q is an option for you to specify which queue you want to use. So in this example, it's a counter queue, and the -A is for you to specify the allocation name. And please note, yeah, sometimes you will find that if you don't specify -A or -2 or -L, it's still working. I mean, that's good, but I mean, if you specify them, you have a clear idea about how much resources and you want, and which queue and you want to use, or which allocation you want to use. And that would be better for you to understand how your job is, how your job works. Also, once the job starts, you will see 2 lines like qsub waiting for job starts, and then it's ready. The job is ready, and then please note the host name has been changed. So before that, you're on one of the login nodes, like the TSCC-login one. Now, once your interactive job starts, you are on one of the compute nodes on TSCC. It's like TSCC-1-22. If you see that host name change, then you know that, oh yeah, I'm on a compute node, so I'm not on a login node anymore. Besides the options I just mentioned, sometimes you can specify a certain node property you want to include in your job. That's to guarantee that the job will use some node properties. For example, if you want to use InfiniBand, so you can specify that node property in your qsub command or in your job scripts. So here is an example for you to prepare a job that will asking for InfiniBand connect. So how about how do I find out those node properties? So if you want to find out those properties, you can use a command called PBS nodes. It's a PBS nodes -A, because that will print out a very long list. And then I'd suggest that you pipe the output with to the last command, so it will be displayed page by page. And if you know the compute nodes you want to use, you can also you can use the PBS nodes and that compute nodes to find out the node properties. So here is the example to find out the TSCC-10-12 node properties. As I highlighted in red here, properties equals to Davidson node, Cascade node, InfiniBand, memory 192, RAD10, and some Condo nodes and Glean node. So what if I want to use a compute node that has 192 gigabyte memory? So I may specify the node properties like with a column and then NEN 192. Once my job starts, I might be my job might be running on the TSCC-10-12. Of course, we have many other nodes that has 192 gigabyte memories, so it might go to those nodes as well. And the next 2 slides are another homework exercise for you guys. So we won't show it here, but I encourage you that finish the homework after this training. So what is it? So here is practice how to start an interactive job for 1 hour or for some time you can specify. So if you don't know your allocation name, remember you need to use the gbalance command, right, to specify the allocation name. And if you remember that the -L is the option for you to tell job schedule how many nodes and which queue, how many nodes and the time you want to use. And if you need to specify the queue, you need a -Q option in the QSub command. And once you prepare the QSub command, you submit your job, and your job will start on one of the compute nodes. And here's the question for you. So once job started, how to verify that you are not on the logging nodes? And once your job starts, we need to do something, right? So we don't want to let it dry run. So let it wasting our computational resources. So when your job starts, here's the rest part of this homework. You can copy an example. You can go to your Scratch directory first, then copy an example from here, from the project directory to your Scratch and untar it, and then you can run something, yeah, like for the test purpose. Like I listed here is if you want to run that calculation, in serial, you can type that ./serial_pi.out. That will help you calculate. That will help to calculate the value of pi based on special numerical algorithm. So it's just for the test purpose and for fun. So, but it also provides a parallel version. So you will find that it can another executable in the same directory can be run in parallel, and you're welcome to try that and see if you can make it or not. Okay. Okay, so next we are going to learn how to submit a batch job. So batch job, the command for submit a batch job is easy. So you use a same QSub command, and then you prepare a PBS job script. You can name it to any name you want, as long as it's okay in the Linux. It's in the Linux. So I call my job script as qsub.submit. And on the other side, you have to carefully prepare your job script, because that's everything you need to run your job. You run your batch job. So here is an example of the job script. And I highlighted this job script into two parts. So the one highlighted in green basically tells the job scheduler how much resources you need. And you can see that it begins with upon PBS, and then those options you will also see in the when you're submitting the interactive job, right? So it's almost the same. And after that green part will be your real code. It will be your code or your program. About how that part is about how will you use the resources that is allocated to you. So in this example, I'm running I'm running some programs with MPI. So I use the MPI run command and running with 32 processors, MPI processes. So here's a question for you guys. So that's a help. I think that will be helpful for you to understand why I divided a batch job script into two parts. So I have a below job scripts on TACC. So you see, since I use the nodes equals to 2 and the PBN equals to 20, that's like a processors per node. So my job will run in parallel using 2 nodes with 40 cores. Is this true or false? So what do you think? Yeah, guys, I understand that that sounds very confusing, because if you are new to the job scheduling or job submissions and how jobs work, but just remember that there are 2 parts of your job script. The first part is how much resources you want. I mean, that's how much resources you want for your jobs. And if your job starts, the job scheduler will allocate those amount of resources. For example, allocate 2 nodes for your jobs for 24 hours in this job scripts. But whether your program or your code can make use of those computational resources really depends on the second part in your job script. I mean, really depends on the part highlighted in black. So it depends on whether your program can run in parallel. It depends on your program itself, or it depends on depends on your code. So that's the thing you need to pay attention. So please do not assume that if once your job is running on 2 nodes, your program can be run in parallel automatically. That's not true. Okay, so next we will have some job monitoring commands to learn. When your job is running, you can use the QStat to check which nodes is assigned to you, or actually no, is queue stat to check which queue your job is running on, and what is your job ID, and how much time your job has lasted, and how much time your job has running. So if I add another option like -n, that option will help you to identify which computer nodes have been assigned to your job. So in this example, I can find out my job ID, my username, which queue I have been running. If you see the job name as STDIN, all capital letters, that means that usually means that you're running an interactive job. Because when start an interactive job, usually you don't specify your job name. So if you don't specify your job name, you see in your interactive job, you will see STDIN. And also you see how many nodes and PPN you have specified in your job, and how long is this job, and how much time it has been running. And at last you see the compute node that is running the job. So if you want to delete your job, you use the qdel command and add your job ID. And if you want to check more details of the job, you use the check job command. And the next command for your job monitoring is called YQD command. You see, I use one whole slide for this because I think that's a very important job monitoring command. And many users come to us to ask why my submitted job remain queue, why my jobs haven't been started for a while. So, but they actually don't know how to run the YQD command. So here is how. So we use the YQD command and then add the username, and you will find out when your job is in the queue, you will find out several outputs from the YQD command. And those are very easy to understand or explain. For example, the first example I list here is called 0 nodes free. So there's no, actually all nodes are running other jobs. So there's there's no nodes available for your job. Or if you use the wrong allocation name, you will see unknown account. And if you see the insufficient SU balance, that means you may need to add more SUs into your allocations. And the last one, it might be very common because you see that there are many other jobs run ahead of this job, so your job have to waiting in the line, in the queue. And also about the job monitoring, please pay close attention to the CPU load and the memory consumed by your job. So once your job starts, you can go to the compute nodes that assigned to your job, and you run the top commands there. You will then find the memory and the CPU usage and some other useful information of your job. The same for the free. The free command displays the total amount of the free and used physics and swap memories in that compute node. And here are some very useful PBS environment variables. So once your job starts, some of the variables are environment variables are available for you. And I highlighted several, and both one, which is PBS _O_what there. That environment variable is very useful for you when you want to go to the directory where your script is saved. So in your job script, you can just use CD and this environment variables, and then once the job starts, you can you draw you will go to that that directory where your job script is saved. Here's another homework exercise and about how to submit a batch job. So it's the same same example as we showed it for the interactive job homework, but what you need to do is you edit that qsub.submit file, and then you change your location name and the email address and some other information to yours, and then you can qsub that job script. And remember, you can use some job monitoring commands to check the details about your job. So here's the command I listed here for this homework. You can try it out after today's training. And one more thing I want to add to the job management is about the GPU usage. So if you want to use GPU on TACC, and they are allocated proportionally to the total number of the cores present. And here I give one example of how to ask for one GPU's GPU node. And please do not set that could visible devices variables in your job script. Otherwise, yeah, we might got some error messages and your jobs might be crashed. So that environment variables are set automatically when you are using GPU. So more things to be noticed is you can use a big memory node in the PDA FMQ, and you can use GPUs if in the GPU hotel queue or the GPU counter queue if your group has purchased some GPU nodes. And last, I give some general questions for you to think about it in this training. So I hope you can have an idea how to answer those questions. And if you don't know, feel free to let me know. So that's about the job management. Because let me see the time. We need some time for the Q&A session. So I will skip the last part of the job scheduling details, but I'm including all the slides here. And actually that's for answering some very basic questions like this. Say, I submit a job A before job B. Why the job B started earlier than job A? Now, in other words, why we don't use we don't use first come first serve policies for our jobs, for our jobs management and submissions. And another questions this can be answered in this session is there are free nodes available, and I'm not sure. I'm sure I have enough SUs for the job, but why my job is still waiting and not running? And I hope through the slides I prepared here, after reading those slides, you will have a general idea about the job scheduling. And feel free to let us know if you have any questions about those after the trainings. Okay, so here is today's take-home message. So what we have learned today? So we have learned about the condo and the hotel programs on TACC and what are they, and we then learn how to request accounts and what is our location and how to check your location balance, something like that. And then we learn some general architectures of the TACC, what is TACC cluster looks like, and what is a component looks like. We show some picture, and then we introduce some in software user environment on the classes. So how to log in, how to transfer files, how to add software, manage your software by environment modules. And then we are talking about the job queues and how to submit the job. Remember, 2 types of jobs: interactive job, batch job, and how to prepare the job script. And last is how to monitor your job once your job is submitted. So please do pay attention to the resource usage of your jobs. So it's very often that your job uses too much computational resources and then get queued. And then we need to take a look at how much resources your job actually used. But if you can monitor your job resources, that would be helpful to prevent such things. Okay, last is our business card. So here's what is our TACC and how to contact us. And as Shuba listed at the very first beginning, we have our new TACC website available now. And I provide the link here. So feel free to visit our website and feel free to reach out to us. Okay, thank you guys.